Hello again. This is Ann Leidick with Pillsbury Winthrop Shaw Pittman. I'm an attorney and previously a nuclear engineer, or at least someone with a nuclear engineering degree. And today we're going to do a little bit of introduction into nuclear fusion and the energy that it releases. And for this little introduction, what you're going to need are marshmallows, small marshmallows, 10 or so of them. And you're going to need something to represent energy, which in this case is going to be an orange M&M for us. But you can use anything, an uncooked noodle if you want to. But we're going to use orange M&Ms because we have M&Ms anyways. And so what we're going to do is we're going to create fusion with marshmallows. So throughout its life, a star generates new elements by fusing the atoms together in its core. Do you know what fuse means? It means to join together. And stars are mostly made of hydrogen and helium. So we're going to have hydrogen atoms right here. Now, hydrogen and helium are the table of elements. You may be familiar with the table of elements or maybe not. This is hydrogen right here, and you can see that little 1 at the top. And that little 1 is how many protons it has. And it's going to be how many marshmallows it has as well. And then there's helium, and that you see the little 2 at the top of helium. That's 2 protons. So this represents a proton. Also kind of represents hydrogen. The number of protons an atom has in its nucleus determines what kind of element it is. So hydrogen has 1. This is hydrogen, even though it has only 1 proton. A hydrogen atom has 1 proton in its nucleus, and this is 1 hydrogen atom. So we're going to take 2 hydrogen atoms. And what we're going to do is we're going to take these 2 and we're going to create fusion with them. Now 2 hydrogen atoms joins together to form 1 helium atom, because as you'll remember on the periodic table, there was 1 for hydrogen and 2 for helium. So let's see how a star makes helium. Boom. It shoves them together with strong force. And the temperatures are so hot and the pressures are so great inside of the stars that the atoms move tremendously fast and just crash into one another. And sometimes they fuse into 1. This used to be my 2 different marshmallows. They became 1. See? So now we have a helium atom because our 2 marshmallows became 1 atom. Now, nuclear fusion doesn't just generate new, heavier atoms. Every time the 2 atoms fuse together, the reaction also releases energy. So can we get this on the table? Let's point at the table so we can see this a little bit better. This is our helium atom, and this is the energy that came from it. Now, that's our gamma ray. So we're going to do this again. We're going to take 2 more marshmallows, 2 more hydrogen atoms, and we're going to smash them together. And they're going to become another helium atom. And they're going to release more energy. And then we're going to do 2 more. We're going to take 2 more hydrogen atoms, smash them together. Dude, it's so hot and so forceful that it becomes a helium atom. Oh, we'll put this one right here so where we can see it. And then there's some more energy that came out of it. So now we have 3 helium atoms and the energy that came from them. How many protons are here? Well, there's 2 here and 2 here and 2 here. So we have 6 protons total. Now, if we smash 2 of the helium atoms together, boom, really quick. And then smash another one into it, boom. It's a pretty big marshmallow at this point. This is 6 different hydrogen atoms, 3 helium atoms. So we have 6 protons, which, if we can get the camera back up again, you can see 6 is right there. It's carbon. So that's carbon. We have made ourselves a carbon atom with our marshmallows, with our many hydrogen atoms and then helium atoms. So that's nuclear fusion right there. You can go ahead and eat your carbon atom if you like marshmallows. If not, you don't have to, of course. And also, when the carbon atom was created, more energy was created as well. The reason when the 2 helium atoms came together, they would have normally created beryllium, but the last helium smashed in really fast for a reason, because beryllium's unstable and it would have disappeared. So you have to do all 3 of them at once. But otherwise, that's it. This is referred to as the triple alpha process because helium nuclei are also called alpha particles. So these are 3 alpha particles, and it's the triple alpha process. And that is the basics of nuclear fusion. You take atoms, smash them together, make new atoms, and you release energy. And that's it. Thanks for bearing with me today. Appreciate it.